Yes, like Ms. CP said, I actually came to this symposium last year and saw Grant's presentation and met Dr. Vinovich, and that's when I decided to do this program. Lots of the work in his lab is inspired by a type of bacteria called methanotropic bacteria that uses methane as its only source of energy and carbon. And that conversion is right here in its carbon cycle. And there are two types of enzymes it has to aid in this. It is one which contains iron, and then the particulate methane monooxygenase contains copper, and they're located in different places. So ideally, the bacteria would want to have both expressed at the same time. But in order to have the particulate methane monooxygenase, it has to be able to get the copper ions from its environment. And it uses the methanobactin protein to do this. And it actually goes out into the environment and gets these copper ions. And its active site is right here. You can see it in the full molecule right there. And it actually has two different donor types, like a nitrogen and a sulfur, for example. And those bond to the copper, which allows it to transport. In his lab, lots of the grad students are making their own mixed donor ligands. QI2M has a sulfur, and only one has pyridyl groups on each side, sorry. And then P2M has an extra methyl spacer on each side. But they can also use selenium, as this one does, instead of the sulfur, with none or one methylene spacers on each side. Grant's research last summer was focused on PIP2SC, and he actually created 6 entirely new complexes. Lots of times in the chemistry labs at school, it's kind of misleading because we're doing labs that the teachers already know the answers to, and there are questions and parts of that that are kind of shaped around that. But our research, we didn't really know what we were going to get. Grant also got 2 new crystal structures. PIP2SC indium iodide in a 1:1 ratio, and indium bromide in a 2:1 ratio. What I wanted to do over the summer, my goals were to do the 1:1 and possibly even 1:2 indium chemistry for the SEPIC and CP ligands, which have a methyl group instead of a pyridyl group like his had. And it seems kind of strange that we do indium chemistry when we're looking at bonding with copper, but by doing indium and zinc or cadmium or all these other different metals that we're doing in the lab, we can assess the coordination preferences of the new ligands, and we know how they would behave better if they were to bind with copper. This is the synthesis for my SEPIC and CP. The SEPIC I actually made from more simple parts, from scratch almost, and the CP though I had to use the intermediate from some of the grad students. And I was able to do the 1:1s and actually attempt for the 1:2s for the SEPIC compounds, and I did the 1:1s for the CP compound. And all 9 of my new complexes were characterized by elemental analysis, solubility testing, melting points, infrared, and nuclear magnetic resonance spectroscopy. I got 2 crystal structures as well that were very similar. I got the 1:1 for the indium iodide and 1:2 for the indium bromide, as Grant did. But his were for the PIP2SC instead of the SEPIC. one of the great things about working in DR's lab is that we get to use lots of the equipment that we don't have here at school. We're actually treated as undergraduate students, which is kind of fun to keep up with. We used a reflux condenser, which we use to speed up reactions, and a rotovap, which can take the solvents out of a solution that we have here, and it puts it into there. We also got to use an infrared spectrometer, which put a little bit of the sample there, put that on top of it, and it'll give us data on it. And we got to use an NMR spectrometer, which was really cool. That's definitely a piece of equipment that we're not going to be getting at the school anytime soon. I also got to use a glove box, which is really interesting. Especially the indium iodide was very reactive with air. So even after a few minutes of having a crystal out in the open air, it started to turn to a liquid. So putting your hands into an inside-out glove every day was kind of a bit confusing. And we also used some vacuum lines, and we used that to take the air. I mean, we used to pull some of the solvent out of solutions we had. And we actually would put a liquid nitrogen trap so that none of the solvents would end up in a pump. And we got to handle liquid nitrogen on a daily basis. The Cepic ME indium iodide, this is my crystal structure right here. As you can see right here, it is very similar to the PIC2SE indium iodide that was, the crystal structure was discovered last year. And the indium bromide as well had very similar coordination preferences as the PIC2SE indium bromide. So we were able to characterize 9 new indium complexes, and from that we were able to discover that replacing a pyridyl with a methyl group has no significant effect on the indium chemistry. And for some of you who are looking to do some future work, I would really highly recommend that you consider the UNCC program. Really, for rising juniors, there's not much better you can do. They really put you straight into the lab, and you're learning as you work, so you don't have to go through a few weeks of classes first. And which is good for the summer. I mean, you get more lab experience too, which is really good. So for the CP-ME, I didn't get to do the 1 to 2 compounds, so that's definitely some future work for someone here to do. And for MPIC and MEPI, which are very similar, they just have a sulfur group instead of a selenium, as mine did. And we didn't only work in the lab, we had some fun too. We went hiking once or twice, I think twice. Some acknowledgements. Professor Rabinovich was a great help over the summer, and thanks to him for all his help with me and Grant. And Keenan, he was a grad student, helped me. He really knew a lot about the few ligands that he was working with. And Ashley Michaels helped with my presentation. And Dr. Golan and Professor Reingold from the University of San Diego did some of the crystal structure work. We didn't really do much of that at UNCC. And thanks to the National Science Foundation, UNC Charlotte, for funding.
Exactly what indium chemistry
is. The indium chemistry is basically like all the different characteristics of the complexes that it forms with indium. So like the bond lengths, bond angles. I mean, we also have some other stuff that really doesn't make as much sense to high school students, like infrared spectroscopy and NMR spectroscopy help to characterize them as well. And that really is useful to determine how it reacts and how good of a job it does at binding with copper ions.